Let's take a look at the very first question, number 1. Now, the way I do these problems, if you don't need to do it this way, that's totally fine. It helps me to make sure I don't miss anything if I list out the left side and the right side. Okay? So, for this question, the correct answer is C. If you had the other test, the correct answer was B. But let's look at why the answer is C. First of all, what does that U mean? What's one? Okay, union. Okay, and it means or. So when it's or, you always add. Exactly. So that means I'm going to combine set A with set B, and it's going to make one long set. So AUB is going to be 1, 2, 3. And check and make sure I'm not leaving anything out. 4, 5, 6, and 8. Okay? Is that everything? All right, and I want to see where does that overlap, or what does it have in common with set C? So 1, 3, 5, and 7 are the elements of set C, and so now I can look at that, and it's very easy to see what they have in common. So what is that? 1, 3, and 5. Okay, 1, 3, and 5. It's just right there. It just falls out right there in front of you. Okay? Okay? All right. Union means together, so that's what I put A and B together. Those are the only ones I'm putting together. But the upside down one, that's the intersection, okay? And that means I'm looking for the overlap. What's in both at the same time, okay? And so what do both have in common? Is that clear? Okay, any more questions about that? Everybody's good? So you need to make sure you're making some notes about what it is that you need to write down to help you remember that. Yes? What do you mean? And so if we change that to another U, okay, so then that means I would combine all of that with this. So I would add 7 to that set. Okay? Okay, good question. So he asked, what if this symbol here was another U? All right, for union, then that just means I've already got a 1, I've already got a 3, I've already got a 5. The only thing I'm missing is 7. Okay, I think so. What's in both sets A and B that's also in C? That's what I heard you say.
Wait,
Okay.
Can you write the little U things like to the side?
Okay.
Or you have to.
Okay. All right. So let's go ahead and remember we're recording, so I gotta kind of keep it moving. So number 2. So number 2 says what's not in the intersection of A and C. So you're gonna do what's in the parentheses first. Okay. So inside the parentheses, I have A and C. I want to see what they have in common. So again, here's A, here's C. So they're already listed out. So what do A and C have in common?
1, 3.
They have 1, 3, and 5.
Yes.
1, 3, and 5 in common. Now, so what's not 1, 3, and 5? Everything else. Now, everything else, you have to look in the universal set. Okay? So everything else. So don't forget about that set right there. All right? So the correct answer for number 2 is B. And if you had the other version of the test, it would have been D. So if your test says for question 2, choice A, if it says 1, 3, 5 right here, okay, then you have the other version of the test, and your answer choice was D.
So that means
Okay. Okay, hold on, one person at a time. If you guys do me a favor, raise your hand so I can see who's talking.
that means that's everything is not in set.
Everything that's not in this set. Okay, so this is A, U, C. I mean A intersect C. So what's not in that set? Okay, Zachi, what was your question?
What's the answer for number 1?
For the other test, number 1 was B. All right, let's move on. Okay, number 3. Which set represents the intersection of X and not Y? All right, so this is a little bit different because the tick mark is on the Y, versus this one where the tick mark was outside on the parentheses. So that applied to everything that was in that set. Here, the tick mark is only applying to the Y. So for this one right here, for number 3, you want to figure out, okay, here's set X, okay, 1, 2, 8, 4, and 5. And we want to see how that overlaps with everything else except for Y. So what does set X have in common with everything outside of Y? Okay, what's not in Y? All right, let's do this. Here's X. So set X is 1, 2, 4, 5, and 8. What's not in Y? 1, 2, 5, and 6. Right? That's not in Y. Okay, everybody with me so far? So, what do those two sets have in common? 1, 2, and 5. Okay, so the answer for this question number 3, the answer would be what? A. Okay, 1, 2, and 5, because they have 1, 2, and 5 in common. So for the other tests, no, what do they have in common? There's no 6 here. Okay.
You know what the class average is?
Okay, so we have 1, 2, 5, 1, 2, 5, and 6. What do those two sets have in common? Okay, so there's a question about the test question. Okay, guys, everybody needs to hear this. All right, so this is asking for what's in the intersection of X and not Y. So first I listed everything that's in X. 1, 2, 4, 5, and 8. Then I listed everything that's not Y. Not Y. 1, 2, 5, and 6. What do they have in common? What do those two sets have in common?
Wait, but what you just said is what's not.
So
No, I-
1, 2, 5, 6 is not.
Okay, listen, ladies and gentlemen. Okay, is 1 in set Y?
No,
Is 2 in set Y?
no,
Is 5 in set Y?
no.
Is 6 in set Y? Okay, that's everything that's not in Y. Okay? No, the question says, what's in the intersection of X and not Y?
You're wrong. I got it
Wait,
right.
so
What's
why
the
don't you
answer?
just say,
Okay.
if it is the intersection of X and not Y, why wouldn't it be 4 and 8?
Okay, but 4 and 8 are in Y. It has to be things that are not in Y. Okay?
What?
Because 6 is not in X, so it can't be part of the intersection of X and not Y.
But then if the little one is outside the parentheses, it's both of them?
If the tick mark was outside the parentheses, we would be asking for what is in the intersection of X and Y. It'd be a totally different question, and the answer would be 4 and 8.
Okay.
Okay? So, are there still questions about that? So do we need to clarify why the answer is 1, 2, and 5?
No.
Okay, so watch. So we're looking for the overlap, the intersection, what's in common between these two things. The first thing is X. X is 1, 2, 4, 5, and 8. Is that good? Okay, and the other thing we're looking at, is not Y. So I make a list of everything that's not in set Y. So what's not in Y? 1, 2, 5, and 6. Okay, so now, what do those two sets have in common? 1, 2, and 5. Okay?
Did you get the milestones with that?
Oh.
Okay, so let's stay on point. I'm recording, okay? Please stay on task. All right, number 4. The set represented, it's all over the place. But determine the set represented by the shaded region in the Venn diagram. Okay, so we're trying to figure out which one of these matches with that one.
Oh, I have an
All right,
answer.
so the answer for this one, if you have this version, the answer is B. Okay? If you have the other version,
It's C.
the answer is C. Okay? So let's look at why B is correct. Okay? So why is B correct? First of all, we're looking for the union of B and C. All right? So that means all of B and all of C. That's the first part. Okay? Then it says not A. So we're going to take out A. We're going to take out any of that was in A because it says, nope, we can't have any of A. So that only leaves that region right there. Okay? Good. In words, that would be B or C, but not A.
Wait, is that C on the other one?
I'm sorry, I don't know what you mean.
And for the other test, is that so?
For the other test, the correct answer was C. Yes, ma'am. Number 5. Each square below is equally likely to be selected. If a square is chosen at random, what is the probability that a shaded square is selected? So this is just like the bullseye problem. This is just like the plates on the table at Six Flags problem. All right, it's all about the probability of what you want divided by the probability of all possibilities. So the probability, what is it that we want? We want to select which kind of square? The shaded square. So what do you need to do? Count up all the shaded squares. So when I counted, I got 20. Okay? And how many squares are there altogether? 36. So when you divide that for number 5, you get C. If you have the other test, you get A.
Wait.
Okay? What'd you say, Kavina?
That's what I did.
Well, it doesn't matter if you reduce it or not because we're dividing it and you get 0.56 or 0.565 something or 0.56 something. Okay? It doesn't matter because there's only one answer that would be close to what you got. So rounding that would not make a difference in your answer, honey.
If you rounded it anyway,
Yeah.
I was putting 55.
But 55 point what?
0.5.
Okay, clearly that's 56, okay? That wouldn't go to anything. Okay.
Wait,
All right.
are you looking at the test for this?
This is the practice test, and this is very representative. Some of these exact questions were on the review. A circular target has a radius of 8 inches. The bullseye in the center has a radius of 1 inch. Assuming a randomly thrown dart hits the circular target below, calculate the theoretical probability that the dart will hit the bullseye. Good morning. All right. So again, it's probability of what you want divided by all possibilities. So it's the area of that circle, the bullseye, divided by the area of the whole circle because it can hit anywhere. But we want it to hit there. So because we want it to hit there, it's going to be harder, right? So the probability is going to be less than 100%. If I ask you, what's the probability that I hit the target? Well, it's not going to be 100% either because you have to consider the wall that it's hanging on as well. But anyway, let's just look at the bullseye. So the area of the parts divided by the area of the whole. Okay? So I need to find the area of this circle here. And the radius is what again? Okay, so the area of the bullseye is going to be pi times 1 squared. Okay, and that's just equal to pi. And then the area of the entire circle is pi times what squared? 8 squared. Ooh. Accidentally touched the board. So pi times 8 squared, which is 64 pi. And of course you can do this in decimals with the calculator and everything, but the answer is in fraction form. So the part over whole is going to be pi over 64 pi. So you can see that the pi's just cancel out, all right? And that just leaves us with the 1 over 64. Because they told us that the entire target has a radius of 8. So from here to here is 8. Okay? Any more questions about that one?
Oh, I get it now.
Okay?
See, this is way easier.
All right, good. And then if you had the other version of the test for number 6, that correct answer was C. All right?
I don't know what's theoretical.
Okay, so number 7, a die is rolled 10 times using the results recorded below. The probability of rolling a 2 is 3 over 10. Which type of probability does this represent? So remember, theoretical, that's thinking, okay? Empirical or experimental is doing. All right, so was this something we just thought about, or did we actually do something? We actually did something. It says a dice was rolled, and these were the results. So that means that's going to be empirical or experimental. So question 7 on the other test, the correct answer was A.
So we don't need to know subjective.
I didn't say you don't need to know subjective, but remember that's in your packet. Okay, and so subjective, I see those hands. Okay, if it didn't go in the grade book, if there's a mistake in grading, just fix it on your own paper. Yes. Subjective. Well, the one that was in our packet was the weatherman says that there's a 40% chance of severe storms tomorrow. Okay, so it's based on an expert opinion. Okay. Or the doctor says that he has a 50% chance of recovering full use of his arm. Okay? No, that's subjective. It's based on an expert opinion.
Oh, subjective is expert.
Yes.
Thank you.
Okay? Sir?
Theoretical.
I beg your pardon?
Theoretical.
What about it? Oh, I didn't hear it. All I heard was theoretical. Okay. An example of theoretical, what is the probability of landing on heads if you flip a coin? Mm-hmm.
Yeah.
Okay. All right. Very good. Number 8. There are 8 shirts in your closet, 4 blue and 4 green. You randomly, that means you just close your eyes and pick a shirt. Okay? That's what that means. You randomly select one to wear on Monday and then a different one on Tuesday. You wear a blue shirt both days. Are the events independent, dependent, both, or neither? All right? So it can't be both. Okay? Say that again.
So what is independent and dependent?
All right. So does the shirt that you wear on Monday affect the probability for the next day?
Yeah.
Yes, it does. Yes,
Still.
it does. Because what happens what happens after you remove the shirts the first day? Because how many shirts did you have initially? 8. So then after you remove a shirt, how many do you have?
7.
7. So isn't that going to change the probability of the second day?
Yeah.
Yeah. So that means those events are dependent. Okay? Those are dependent events. But if we were talking about the shirts you wear and then the pants you wear on Tuesday, those would be independent events. Okay? Your shirt doesn't affect, the color shirt you wear doesn't affect the color pants you wear. All right? If you're choosing them randomly. Because those are 2 different pots that you're picking from. Okay? All right. All hearts clear on that one?
So independent is what?
That's lost one. Okay. So independent events. Independent events are events that where the first one does not impact the second event. All right. It's right there. The first does not affect the second event. So I heard someone say, "Wait." Yes, ma'am. The example for what? For dependent or independent? For this one? Oh, if it was independent, if I said you have 4 blue shirts and 4 pairs of blue or green pants, and I said, what's the probability of you picking a blue shirt? I mean, I guess the example is, will you picking a shirt on Monday affect your pants that you pick on Tuesday? They have nothing to do with each other, okay? Just like rolling a die, or say pulling a black card and then drawing a red card. Those events are independent of each other. But if I say you draw a red card and then I say a red heart next, the red heart is going to be affected because you already pulled a red card. Yes?
It's independent without.
Say that again.
Can you say it again? Independent
I guess you could think of it that way. You could think of it that way. If you're putting it back, then that's separate from this question though. That's separate from the scenario that we're looking at. So when you're talking about with replacement and without replacement, so with replacement would be like an independent, yes, because you're putting it back, so the first event doesn't affect the second event. All right. So that was for number 8. Number 8, the other answer was also C. If the questions were the same, right? Okay. Make sure double checking to see if the questions are different or not. Number 9, determine which pair of events are independent. So sometimes we are looking at a scenario to see if they're independent or dependent, and then sometimes we're just doing the math. So we're going to use the multiplication rule for independent events to determine if something is independent or not. And so you just kind of had to do trial and error. So for this one, number 9, the answer was B. All right? And so why is that?
Because 0.6 times 0.5 equals 430.
Okay. So you're just using that rule. So if the probability of A times the probability of B equals the probability of A and B, then yes, they are independent, okay? So you have to look at the numbers and put them in the right place. So you would multiply these two and you want them to equal that one. So if you got a different number on the left than you did on the right, okay, then it would not be working. It would not be independent. I heard an
Carry over know something.
All right, number 10. Mrs. Carter has several coins in her pocket, 2 pennies, 1 nickel, 3 quarters, and 5 dimes. If she randomly picks 2 coins from her pocket, what's the probability that she picks a quarter and a nickel? So this question, I don't know if I kind of rephrased it for you guys or not, but this one was really not phrased that well. So we were basically looking at, if you pick a quarter first and then a nickel. And so if you pick a quarter first, what would your probability of getting a quarter be? 3 out of 11, okay? And then what would the probability of you getting a nickel? Okay, 1 out of 10. And so when you multiply those numbers together, okay? I know, and I said that it's not phrased very good. Okay, the question wasn't phrased well. That's not what we meant. That's not what we intended. Okay. So for number 10, what did you get when you multiply that?
It's 2.7.
Okay. So number 10, yeah, is A. Okay.
Wait, why'd you put?
If you had the other test, the answer to number 10 was D. Zachi, you good?
I just understand why you didn't use 4 over.
Where did 4 come from?
Because it was probably that she picked a quarter and a nickel, so I added it together.
I understand, and I'm telling you that the question was poorly phrased, and so you probably misunderstood the question because it wasn't phrased well. Okay, sir? It's not recorded. Okay, so all right. Dawson, did you have a question?
So why'd you put 1?
Because if you've taken 1 coin out, there's only 10 left. Ma'am, is it about this? Okay, I'm recording. Okay, so write yourself a note so that you won't forget. Okay.
Couldn't it also be
3 over 10 and 1 over 11.
No, I mean, I guess the math would work out the same, but that wouldn't be the correct setup because it says you have 3/4. All right, so I see what you're saying, the order. Okay, you would get the same answer. I hear that was a good question, Sachi. Okay, number 11. A bag contains 4 red marbles and 3 blue marbles. You randomly pick a marble, and then what? What does it say? And then you return it to the bag, okay? So that's with replacement. Okay, a lot of you are on your phones. I really think you should be paying attention. Yes. It says, and then you put it into the bag before picking another marble. We're talking about number 11. Okay, gotcha. So for number 11, so the first time, what's the probability of getting a red? Okay, then you put it back. So what's the probability of getting a red again? 4 out of 7 times 4 out of 7. Okay? Any questions about that? Okay, we need to get off our phones, please.
Oh, 8 you return it, so it's 4 over 7.
That's right. Any questions about that?
So what's the answer?
Okay, so the answer for this one is A. If you had the other test, your answer was C for number 11. Okay? Number 12, Mr. Winslow has a bag of marbles. He randomly pulls out 1 white marble and what? Does not replace it. Then he pulls out a second white marble. What is the probability that the second marble is also white? So, what are we starting off with? How many marbles?
8.
Okay, 1, 2, 3, 4. So we had 8 marbles to start with. And how many whites?
3.
3. So then when he goes to pick the second marble, what's the status? What's the probability of getting white that time?
2 out of 7.
Okay, 2 out of 7. And then we want to change that to percent. So for number 12, you would get A, 29%. If you had the other test, the answer was D. Okay? All right, any questions about that? Okay, let's keep it moving. Number 13, A, solve for each missing probability. So we're told that A and B are independent. So we're just working backwards to find the missing part. Let's see, for number 13. So remember, it's the probability of A times the probability of B equals the probability of A and B. All right. So that I was writing my formulas down first. So do we know the probability of A? No, that's what we're looking for. Do we know the probability of B? Okay, and I just, sometimes it's easier to change these things to decimals if you want. So you could change that to decimal. And that's going to equal the probability of A over B. So basically, you're just going to divide both sides by 1/4. All right? Is everybody clear about that? Or you can multiply both sides by 4. So how about we do it like that? So multiply both sides by 4. And that gives us x equals 4 over 8, which equals 1/2.
Over.
Mm-hmm. Just to cancel out the denominator, if you just take the calculator and divide both sides by 1/4, if you just divide 1/8 divided by 1/4, just use the n over d key, and it'll give you 1/2 as well. Or it might give you 0.5 and just press the double arrow key. Okay? All right. And then for the next one, number 14, it says the probability of A is 0.4, probability of B is 0.35, probability of A or B is 0.61. So what is the probability of A and B? So for number 14, there's really some extra information in there. Okay, yeah. I didn't need to use the OR to do that problem. So I just multiplied. We did 0.4 times 0.35. Is it equal 0.14? 0.14. Okay, which was A. So 14 was A. If you had the other test, then 14 was C. Okay, yes.
So you most probably just said and B, right?
Mm-hmm. Number 15. Which of the following describes two mutually exclusive events? So here's one that you probably definitely want to take some notes on. Mutually exclusive events do not share outcomes. Okay. For example, you can't draw a red card and a black card at the same time. Okay, those are exclusive events. All right. Oh, okay, yeah, but don't bring that in. Don't bring that in. But I understand what you're saying. Okay. So, uh, so for number 15, the correct answer here was C, because a number can't be 3 and bigger than 3 at the same time. Does that make sense? It says 3 and greater than 3. Okay? I mean, that's fine. Okay, but still, those have nothing in common. 3, it's not telling you find the probability of 3 or greater than 3. That's not what we're saying here. It's just saying, are those events mutually exclusive? Can those both be true at the same time? Can a number be 3 or bigger than 3 at the same time? Right. Okay. Mm-hmm.
Can you say the definition again?
Mutually exclusive events do not share outcomes.
The answer is
There's no overlap. Okay, the probability that the sum of the numbers rolled is an even number or a multiple 3. Can a number be even and a multiple 3 at the same time? Yes, it can. 6. 6 is a multiple of 3, and it's also even. Okay. Can a number be a 6 and even at the same time? We just did that. Yes. Can the sum of two numbers be odd and 7? Yeah, because you could roll a 1 and a 6, or a 4 and a 3. Okay. Okay, so the sum has to be odd and 7. Both of those things can happen at the same time because 7 is odd. Okay. The answer is C, because those two can't be true at the same time. Okay.
So it's saying what two is it asking what two can't be
True at the same time. True at the same time. It's not an equation. It's just thinking about it. Okay.
It says
Okay. Well, if I ask you for the probability, okay, that's for or. Okay.
it says roll.
That's an equation, but we don't need the equation for this, sweetie. We just need the definition. You understand, sir?
It says rolling.
Okay.
Isn't that true? I think it's rolling.
Can a number be 3 or greater than 3 at the same time?
Wait, can it be 3 or greater than 3?
At the same time.
Oh,
Can 3 be bigger than 3? 3 is equal to 3. So if you roll a 3, it's not bigger than 3. Those are two separate events. There's no overlap. If I said 4 or bigger than 3, those are not mutually exclusive because 4 is bigger than 3. Both are true at the same time. Okay. This has to do with that overlap part. This means there would be no overlap. Okay? Like if you're looking at a table, there'd be no overlap in the table. So if I said a male or a female, the males are in one category, the females are in another category. There's no overlap. But if I said people that ordered hamburgers and people that ordered French fries, there could be some overlap because some of the people that ordered hamburgers we already counted. Okay, guys, you're overcomplicating this problem. Just think about it. The main thing is they don't share outcomes. Both things can't happen at the same time.
It's 3 and 3.
It's because 3 is not bigger than 3. Okay? All right. So number 16. So this is a good time to look at this kind of situation. So for number 16, the first question. Well, first we need to go ahead and complete the table. So we have males. So we have 372 males. All right. We have 324 females, and I think that was 696. And we know that 209 of the females said that they got their license at 16. All right. And so you guys, let's see, is there one more number? What is it?
275.
Where does that go?
Boys,
Male,
for yes.
Yes.
For yes?
For yes.
275?
Yeah.
Okay. All right. So then give me the rest of the numbers.
97,
115,
yeah.
And then 212.
right here.
Yeah.
484. Okay. All right. So now it says for number 16, what is the probability that if you select a student, it's a female or someone with a license? Okay. So for number 16, all right. So this gets into the exclusive and not exclusive situation. Okay. So are these mutually exclusive? Someone can be a female or have a license. Are those exclusive? All right. No, they're not, because you can be both at the same time. You can be female and a person that has a license at the same time. All right. So that's not mutually exclusive. So we're gonna have to do some subtraction. So how many females do we have? 324. Okay. How many people have their license? 484. Did anybody get counted twice? Yes, they did. So here are the females, and here are the people that got their license. Who got counted twice?
209.
That's 209. Those females, we already counted the 209 females that got their license. We counted them when we counted the females. Okay? There's overlap. So those are not mutually exclusive events. So we have to subtract them out. And then divide by 696. All right? And so you end up with 599 over 696. You have to subtract out the overlap. That's why I told you guys, make some kind of little mark on there so that you're identifying the people that you're counting. And then whoever gets marked twice, those are the people that you need to subtract out. Okay? I promise you, if you do everything that I show you, it really works every time. Okay? Okay? The probability that a person selected is a female or a person that has a license. So that's an or. So you're going to use the addition rule. And if there's any overlap, you have to subtract them. If there's no overlap, you don't have to subtract. Okay? All right. So number 17. The probability that a person is a male and does not have a license. So how many males don't have a license? 97 out of 696. Okay?
So that's the answer.
That's the answer. So for this person, ma'am? For this test, it's A. If for the other test, it's 599 out of 696. It's right there. And then for number 16, if you had the other test, the answer was also A. I'm sorry, no, B.
97 over 6.
And then for 17, 97 over 696 is the answer for this test. Number 17, that was B. For the other test, the answer was A. Yes, ma'am.
Okay, so if it doesn't tell you like what's given,
Right. If it doesn't say, it would be asked it two different ways. It might say, what's the probability that someone has a license given that they're a male? So if I say given that they're a male, then I'm only looking at the males. That would be my denominator. And then the top number would be 275. So it'd be 275 over 372. Or I could say, what is the probability that someone, that if you, I'm trying to think of how they word it. What percentage of the males have a license? That's another way of asking that same question that you gave me. So what percentage of the males have a license? only look at the males. So that question is equivalent to saying, given that you have that you're looking at males. Okay? Good question. Number 18. So here, this goes to your point, Whitney. So what percentage of females got their license at 16? So that tells you what your denominator is. Okay? So, and so there are a lot of things I've been saying that you should be writing on your note cards, because these are things that are confusing for some of you, and a lot of you on your phones, and people are sleeping. And so I hope that you capture the notes that you need. So anyway, it says what percentage of females, so what's my denominator going to be? Okay, so it's going to be 324. Okay, and then got their license at 16. So 209 over 324. So when you divide that out for number 18, you get 65%. All right, so that answer is B. If you had the other tests for number 18, the answer was C. Any questions about that? So do you guys see the difference between using the total for the entire table as your denominator versus one of the marginal frequencies, one of the other totals? Is everybody clear about that? Okay, please, that makes the difference between getting an easy problem right or wrong if you're missing that one little piece, okay? All right, good. Numbers 19 through 20. In a certain town, the probability that a student plays a sport is 0.65. The probability that a person plays an instrument is 0.4. So I like to just kind of write them out. And it says the probability that they play both is 0.25. Okay, so then the question is, what is the probability that a student plays a sport or an instrument? Okay, so which rule are we using? Are we using the conditional probability, the multiplication rule, or the addition rule? Addition. What's the key word that tells us that we're using the addition rule? The word or, okay? And remember, when you see or, you add, and you always check to see is there any overlap. So you might be told this way, so this would be the overlap. That's both, okay? It might be in the table, all right? It might be in a Venn diagram. So it still works the same way. You're just getting your numbers differently. So it would be, so what will our numbers be? What are we going to do? Point what? Let's use the addition rule. 0.65 plus 0.4 minus 0.25, and I think that equals 0.80. 0.8. All right? And on the other tests, number 19 was D as well. Okay? Okay. Yes. Sure can. Any questions about that? I'm good. So you're good. Get it. Tell me what made you think that it was conditional, because it had the and. Gotcha. I can see that. That's another one of those good mistakes. Okay, so good job. I bet you won't miss that on Monday. Good for you. All right. So let's keep it moving. Lexi, you're good. Okay. So number 20. What is the probability that a student plays an instrument given that they play a sport? All right, so probability of A, I'm going to use the letters. So what's the probability that they play an instrument given that they play a sport? Okay, and that helps me figure out. So you follow the pattern. Remember, whatever the number that goes on the bottom is always the number that comes after what? Given. All right, that's important. The denominator is always whatever comes after given, whether it's in the word form or using the symbols. Okay, that's real important. Some of you probably need to write that down. Okay, so given that they play sport. So let's fill in our numbers. So that would be, so what goes on top? We're using the same information over here. I'm trying to find this. Okay, so what is the probability that they play an instrument and a sport? 0.25. And what's the probability that they play a sport? 0.65. Okay, so 0.25 times divided by 0.65 is going to give you 0.38 or 38%. I can't promise you that. You should you will have a formula sheet. Okay. Yeah, I'll try to write them on a piece of paper, but these are given. These will be provided for you.
Can you repeat the note you said to make about the given?
Yes. The denominator, when you, for this setup, the denominator is always what comes after given. The denominator is always what comes after given, whether it's in a sentence form or given to you like that. Okay? All right. Okay, number 21. Calculate each probability using the Venn diagram. Now, one thing I noticed when I was helping people out walking around, a lot of you, if you were looking at the probability of A, you were only focusing on that. Okay? Remember, A is this entire circle, so it's 0.3 and 0.2. B is this entire oval here, and that 0.2 also applies to B. So it's being used twice. So it's not going to be listed twice if it's being shared, okay? All right. So for number 21, it says probability of A would be 0.3 plus 0.2, which is 0.5. So 21 is B on this test, and on the other test, it is D, as in Dawn. Okay, quickly, 22, the probability of A given B is going to be the probability of A and B divided by what? What goes on the bottom? Probability of B. Okay, so what's A and B? What? 0.2. A and B. The part in the middle, and the probability of B. Be careful. What? 0.6. Remember, B is all of that. You have to add those together. All right, so 0.2 divided by 0.6 is going to be 0.33. All right, so on this test, it's D. On the other test, number 22 is B, as in boy. Number 23, what's not in A or B? Listen to how I said it. What's not in A or B? 0.1. 0.1. So on the other test, number 23 was A. And then for the last two questions, this is just more the same. What's the probability of A or B? Which rule? Conditional, multiplication, or addition? Addition rule. Okay? So what am I going to add? 0.45 plus 0.2 minus 0.15. All right, so for number 24, you get 0.5. And for the other test, you get C. So it's A for this test, the other test is C.
No, you guys moved it over. 24 is 24, that one is 25.
Okay, be careful. Okay, so if you have the other version, Zachi was saying that the questions were switched. So this is your 25. Good call, good catch. And then on the other test, the probability of A given B. Okay, what goes on top? A and B goes on top. What goes on the bottom? B. All right, so 0.15 divided by 0.2 is 0.75. All right. And if you have the other test, the answer is C. Okay?
How many questions are going to be on the test on Monday?